Share screen. Sorry. Okay. So, ipe-paste ko siya dyan. Ayan. Ito guys, ang ibig sabihin lang naman yan, ay parang ganito. You have to max is equal. I'm just making use of any letter to denote the item. P1 times X1 plus P2 times X2 plus P3 times X3, so on and so forth. Or kumbaga kung nakalagay siya sa table, parang ganito. Ito yung profit, for example. And then we have product A. Sorry, dahil ginamit natin X1. Lagay ko X1, X2, X3, X4, X5, X6, X7, X8. Halimbawa yan. 2, 3 piso, 2, 3, 3, 5, 4. Okay. Di ba? Ito, pwede natin siyang mailagay yung objective function as similar sa this. Max of Z is equal to summation of profit. Pwede ko siyang ilagay na P sub I times X sub I mula 1 hanggang 8. Iisa lang yan. Ito. 2 times X1. Medyo confusing lang siya kasi kakaiba na itsura. Hindi tayo nasanay sa ganyan. Pero pareho lang din naman ang ibig sabihin. Plus 2x sub 4 plus 3x sub 5 plus 3x sub 6 plus 5x sub 7 plus 4x sub 8. Iisa lang siya. Malinaw? Same is true dito sa subject, sa constraints natin. Questions? Kasi may makikita tayo mga problems na ganito yung format. Questions? Okay, seems wala. Okay, next. So yun, sa ngayon pinag-usapan natin is about linear function. So ito yung function form niya. Pero may mga cases na tinatawag tayo na ito, non-linear functions. Ito non-linear because of the absolute value. Yun lang naman yung dahilan dyan. Ito naman, not linear kasi x squared. Kung ilalagay natin, di ba linear line? Kung ilalagay ko dito guys. Okay. Y is equal to x squared. Yan yung itsura niya. Is it a line? Hindi. Okay? So, hindi na siya linear. Malinaw? So, yan. Pa-curve eh. So, hindi siya line. So, yun yung reason dito. So, those are called non-linear programs. Example ay ito. Ayan. Ito, 3x minus 4y. Linear siya. Linear din siya. Pero itong portion na to, and then itong objective function is non-linear. Ito, x minus y squared, non-linear. Okay, gusto niyo makita? Yep, pwedeng ilagay natin x plus 1/2 times y squared minus pala yun. Minus y squared is greater than equal to 0. So, yan yung itsura niya. Okay, yan yung itsura. Itong portion na to. Sorry, 10 pala yan. Yan. Questions? Hindi, again, once again, hindi siya line. Naka-curve na. So, those are called non-linear programs. Also, there's a case of integer programming. So, ibig sabihin nito, integer. So, ano ba yung integer? Anyone? Ano pag sinabi nating integer? Ito, may nakalagay lang na constraints. X1, X2, X3 are all integers. Ano yung integer? Yep, exact number. Ibig sabihin, walang decimal. Tama? For example, tao. Di ba hindi pwedeng hatiin yung tao? Hindi pwedeng, parang ang tanong, ang decision variables natin, number of tao. Ilang tao yung kailangan? Di ba hindi pwedeng sabihin 3.14? Kailangan either 3 or 4 siya. Tama? So, sa totoong buhay, ito po yung ginagamit, integer programming. Ito naman, nagigilan siyang integers. Yun lang yung difference sa linear. So, okay. So, industrial applications, napakadaming gamit ito. And then, nope. Industrial applications mean ano yung mga programs. So, ayan. Yun nga, may internet naman tayo. So, mas madali na makapag-solve ng mga OR problems sa net. Pero ito, may mga available software naman tayo kaso very costly. But for now, yun nga, Microsoft Office application na ang gagamitin natin. So ano ba yung, para saan ba yung Microsoft Office? Ito, Excel, ginagamit, for example, on checklist. And ito, solving Sudoku problems. Gagawin natin yan. Ito, pwede kang gumawa ng games through Excel. Ito, parang Tetris. Ito yung mga gagawin mong code. So, Control A, Control D, Control S, so on and so forth. Okay? Ito, meron ganyan talaga. And then ito, for medyo luma na siya eh. Flight simulator. Yes. Yung? Ano yung flames? Game lang ngayon. Oo, mas madali yun. Simple lang ngayon. Pero ito, kaya natin gawin. Gagawin natin. Pero, yes, sure na madali yun. Yung flames yun ba yung mga tatarahan tapos magiging result ay may marriage, friends. Okay. Simpleng, yan po yung napakasimple lang. So, yun. Gagawa tayo nito. Sudoku. Ito medyo komplikado to. Flight simulator. Paintings. Yan. So, another sub-objective natin is to learn more than Excel. Yung mga advanced Excel na. Like for example, VBA. We'll do codings through VBA, Visual Basic. Maalam naman siguro kayo ng Visual Basic, ano? Yes, sana. So, ayan. Para magawa natin tong mga games na yan. And then yung flames. We'll teach you how to do VBA. Mga karos. Okay. So, questions? Wala pa. Okay. Next. Dito na tayo sa mismong topic natin for this week. Asan na yun? Formulation. Oh, sorry. Formulation. Okay. Yun, na-introduce na sa inyo kanina how to formulate linear problems. Yung ginawa nating mathematical models. Yung mga x plus y, yung k plus s, yung ganun. Yan, let's try to improve ano-ano pa ba yung mga other problems natin. For this one, we'll try to make use of a use case whereas yung McDonald's providing an optimal meal selection and then many other types of applications ng linear programming. Okay. So, okay na to. Ito. So, tayo, kalimitan, we start with a simple model of the problem at hand. Then afterwards, i-improve natin in order to come up with the improved model. Then later on, i-improve na uli natin i-improve. So, ganun po yung proseso dito sa modeling. Now, isa tong case. Maybe hindi nyo to alam, but 2004, there was a documentary called as Super Size Me. Available din po siya sa internet. And then, I also provided the link of the documentary dito sa ating asa na yun? Operations Research. Ayan, pinrovide na rin po na ayaw gumana. Ayan, nakaprovide na rin po dito yung link. Ayan, yung Super Size Me. You just need to watch it. Ito po yung link niya. Hindi naman to record. But then, just to give you an idea of what this documentary is. So, ayan. So, meron daw, nagkaroon daw sila ng 30-day diet sa McDonald's. Na ang kailangan lang nilang kainin ay McDonald's na items. For example, fries, burger, yun lang yung kakainin nila. So, ayan. Eat everything on the menu at least once. And then, bawal silang kumain ng outside food rather than sa McDonald's. Okay? And then, isu-supersize, ibig sabihin, mas palalakihin pa yung meal nila every time na ino-offer sa kanila. And then, as a result, he averaged, or that person averaged na 5,000 calories a day. Okay. Ganito kasi, sa Pilipinas, hindi siya masyadong concern. Or pag bumibili tayo sa McDonald's, tinitingnan natin yung presyo kalimitan. Pero nung kami nasa US and even sa Mexico, and I think pati sa Korea, ganun din, dumaan kami sa Korea. Ayan, nakalagay dun sa menu nila or ayan, dun sa display, gaano ka taas yung calorie content, yung sugar content nung bawat item nila. Dito lang sa Pilipinas, hindi masyadong nilalagay yung mga ganun presyo lang. So, ayan. As a result daw, nag-gain yung tao na yun ng 24.5 pounds. And then, he also suffered depression, lethargy. Ayan. And then, on the 21st day, out of the 30 days, nagkaroon na siya ng heart palpitations. Ayan. But then, on the bright side, ayan, may Oscar nomination siya, tapos box office. And then, ayan, drinap na ng McDonald's yung supersizing. And of course, yun nga, yung criticism ng movie, yung downside. Ayan. Ano yung application ng OR dyan? Let's say you are to provide a good diet plan using McDonald's items for a week. A week diet plan. Ano yung mga kailangan mong data? Siyempre, yung mga pagkain nila, di ba? Presyo. And then, yung content, kasi diet. So, sugar content, calorie content, decision variables, ano-ano yung pagkain, ilang price, ilang burger, or any meals nila. And then, objective function, let's say for example, at the least possible cost. So, cost, so price, yun yung tingin natin. And then other constraints like for example, sugar content, gaano kadami dapat yung sugar content niya, yung calorie content. For a week, kailangan halimbawa ay 1,000 lang for a week. Hindi ako masyadong familiar din Pero yun yung mga related items sa McDonald's diet plan. Ngayon, just to make it simple, and i-minimize natin yung cost for a meal. Ibig sabihin yung presyo. And then, only few choices will be listed and kailangan daw 600 and 900 calories, less than 50% of daily sodium, and the likes. And then, they come up with a model similar to this. Nag-search sila, ang hamburger, 250 Big Mac. Yan lang yung mga provide na meal sa kanila. Tinignan din nila yung calorie content, protein, sodium, and then the cost. Then, yung restrictions, nakalagay din dyan. Afterwards, na-develop nila yung linear programming problem. ito medyo komplikado kasi ang daming unknowns, like for example yung fat content niya. Medyo may mga ilang conversion pa diyan eh. And then to come up with an optimal model. Kung mapapansin niyo to guys, LP solution 1.13 na hamburger. Di ba sabi ko sa inyo, hindi naman pwedeng ganyan na ano yun, hahatiin mo pa yung burger. So, kailangan naka-integer siya kung titingnan natin sa tunay na buhay. So, 1 burger, 2 na, I think R is for fries. Yeah, for fries. 1 hamburger, 2 fries with a cost of $3. Kung mapapansin niyo yung cost, mas mataas kaysa dito. Di ba ang objective natin to minimize the cost? Whereas sa IP, sa integer programming, lagi na hindi siya optimal. Isa siya way, pero kailangan hindi rin siya naka-fractional form. Okay? So, kumbaga, optimal solution ay ito, pero ito naman yung problema. Hindi siya naka-integer. Ngayon, guys, isa sa mga tasks dapat dito sa OR, how will you collect data? Okay, so let's try to develop our own first task natin. Nakalagay din naman dito. Is to collect data. I'm hoping you can see my screen. You have to collect data regarding the calorie content, protein, price per item, total sugar, and then yung trans fat for, let's say, 5 different McDonald's burger. 4 sizes of price. Tama, we have regular, medium, and then regular, medium, large, tsaka BFF. Ano yung calorie content niya, ano yung protein content, magkano kada isa, ano total sugar content, ano ang trans fat content. So as with 5 different regular size beverages, regular size, like for example, Coke Float, Coke, Sprite, Fanta, ayan. Coffee, siguro ilagay na rin natin dito. Then also 5 breakfast meals. So all in all, 19 sila. So you have to put your 19 items. Yeah, 19 items and collect data related to calories, protein, price, total sugar, total fat, trans fat. So again, wag po kayo mag-a-attach dito ng kahit na anong Excel doc file. I-fill up nyo lang po itong form na to. Or yeah, ikakopy nyo lang to and then you just need to fill it up. Isasubmit po directly dito. Questions? Again, that's the first task, data collection. Kasi again, not all data ay available. You have to search for it kung minsan. Gather data. Questions? Guys, questions? Yes, ang due date dito, I think ay September 13. Yes, individual for now. Kasi kanya-kanya tayong data collection. Please guys, wag niyo pong tulungan ng isa't isa dito kasi kailangan matutong mangolekta ng data. Okay? I think McDonald's. So ito yung one option na may yes, nakakagutom. Okay. So ayan, for example, Big Mac. Again, sa US, concerned sila sa nutrition content kaysa sa presyo, unlike dito sa Pinas. So ayan, makikita dito, 550 calories, 9 grams sugar, 25 grams protein, trans fat 1 gram. Magkano siya? Okay? So yan, pwede magamit itong link na to or yeah, just search for it sa net. Then beverage, nakalagay din dito. The Fanta, Sarsi, yung orange, yeah, included na yung mga shake nila. Yung iced tea as well. Yung tubig, kung meron man. Ayan. Questions? Siyempre, kayo mag-search na hindi ko yan ipoprovide. Questions? Wala? Okay, gets nyo gagawin ha? Data collection pa lang yan. Gagamitin natin yung sa sunod na activity. Okay. So, ngayon, wala pa tayo sa objective natin, which is formulation. Let's say ito naman, scheduling postal workers. Let's say ito may 5 consecutive. Kailangan daw yung each postal worker works for 5 consecutive days, followed by 2 days off. So parang yung schedule ng mga empleyado, halimbawa manager ka, then you have to schedule sino yung pang Monday to Saturday, Monday to Friday, Tuesday to Saturday, Wednesday to Sunday, Thursday to Monday. Nagigets? Di ba ganun sa mga kayo yung nag-schedule? And kailangan daw may 2 days off. So guys, ito applicable din siya for production. Kasi maghahawak ka kayo ng linya, maghahawak kayo ng production line. Ayun, so kailangan maalam kayo mag-schedule sino yung ilang tao ba yung kailangan ko given na restricted yung number of people dun sa linya. Okay? And then kailangan may 2 days off sila. Paulit-ulit yung schedule weekly. Ngayon, your goal is to minimize the number of postal workers for each day. And then, for the time being, ipe-permit daw yung fractional workers. Ibig sabihin, okay lang na 1.3, 10.7, okay lang yung mga ganun. Okay. So, wala pa po tayo dun sa mismong pagsasolve. Dun muna tayo sa initial step kasi yung solving nga, napakasimple na dun. Okay. Now, let's try. So, ayan. So, once again, each postal worker works for 5 days, consecutive 5 days, and 2 days off. Paano daw natin mai-report yung objective natin dito? So, yung iba, ginagawa nila ay parang ganito. Okay. Nilalagay nila yung day, Monday to Sunday. And then, ayan, schedule 1 para may kulang tayo dito ng data. Salita nga, para may kulang na data. Hindi, okay pa. Okay, and then ilalagay nila dito, ilan daw yung for Monday. Let's say, ito yung Monday to Friday. Sorry. Monday to Friday. Then, or sige, pangalanan na natin siya as 1, 2, 3, 4, 5, 6, 7. So, ito yung schedule ng first pa natin. Okay, yan yung schedule nila. And then 2 days off. 2 days off. Sige, pala natin yung hulay. Kasi days off. And then yung second natin ay ayan. Yung third schedule natin ay ito. Nagets, Wednesday to Saturday to Sunday, 5 days. Then Thursday hanggang Monday next week. Then 2 days off. And then ito, hanggang dun. Then 2 days off. Then ito, hanggang dun. Then 2 days off. Then ito, hanggang dun. 2 days off. Malinaw? Question? Ito po yung example ng pagmamodel kasi ang hirap ilagay sa table eh. So, ayan yung model natin. 2 days off yung block. Ngayon, ilan daw yung kailangan sa Monday? Okay, ilan daw yung kailangan sa Monday? Sa Monday, kailangan 17 lang na employee. Ito, 17, 13, 15, 19, 14, 16, and 11. Ito, So, ayan yung itsura niya. Okay. So, kung lalagyan natin dito, palitan natin siya. Gawin natin siyang x1. Then, ito, x2, x3 hanggang x7. Then, yung ating decision variables. Ilan yung naka-schedule ng Monday to Friday? Ilan yung naka-schedule ng Tuesday to Saturday? Ilan yung naka-schedule ng Wednesday to Sunday? Nagigets? Then, ang schedule nito ay, ayan, so on so forth. Ayan, gawin natin siya. Kung ilalagay ko siya sa linear model, ito gagawin ko lahat 1, 1, 1. Kasi, okay lang yan. Huwag na ako nalagyan. So, parang ito, sa Monday, ito yung Tuesday, ito yung, ilagay ko lang yung mga araw nila. So, dito sa Monday, ilan yung naka-schedule? We have x1, x1, plus x2, hindi, naka-block ko, plus x4, plus x5, plus x6, plus x7, ay dapat hanggang, kasi demand, so hanggang 17 lang. Question? Okay, and then Tuesday, paano? Ito lahat ng may yellow. We have x2 plus x3 plus, sorry, Tuesday pala, sorry, x1 na start natin, plus x2, ito, plus x5. And then, ayan, kakopy ko na lang para mas simple. x5, 6 and 7, wala kang x4, okay. Dapat 13. Nagets? Question. So, translate ko na siya sa papel. So, kasi nagawa ko na siya ng first one. So, ilagay ko siya dito. Copy ko lang. Para kita natin. So, ayan. Ayan. Yun yung constraint. Anong objective? Ang objective natin, parang ganito lang. Ilan lang ka-schedule? Ano ba yung goal natin dito? Sorry. Tingnan lang natin. Minimize. Minimize pala. So, may mali tayo. Akala ko maximize. Sige, minimize. Minimize pala to. So, minimize, pangalanan natin siya as A is equal sa naka-schedule sa X, sa first schedule, second schedule, third na schedule, 4, 5, 6, 7. 7 kasi 1, 2, 3, 4, 5, 6, 7. Okay, ngayon, constraints naman tayo. Isit ko siya dyan. For the constraints, ito. If hindi kompleto yung problema, ganito kalimitan. Sorry, erase ko lang siya. Ayusin ko lang. Ito yung general rule. Ito yung objective. Ito yung constraints. Pag hindi ka sigurado, ito yung gawin mo na lang. Kagaya ng case natin. So, if that is max, ang constraint, kalimitan ganyan. Less than equal. And pag min, kalimitan, again, it is not all the time. Not all the time. So, kung ang mean ay ganyan naman, greater than equal. So, for our case, ilagay natin x1. So, what are the constraints? Lagyan natin. Sorry, ito ay constraints. subject to. We have x1, ito. So, ayan yung may check. x1 plus x4 plus x5 plus x6 plus x7. Sabi ko nga, ito yung gagamitin pag unsure, greater than equal sa 17. Okay? Next, dito naman tayo sa chest day. Ito. So, ilagay ko lang dito, x1 plus x2 plus x5 plus x6 plus x7 greater than equal sa 13. Then, dito naman tayo sa Wednesday. Sorry. We have x1 plus x2 plus x3 plus x6 plus x7. 1, 2, 3, 4, 5 greater than equal sa 15. Next, Thursday. x1 plus x2 plus x3 plus x7 greater than equal sa 19. Ito siya. Okay, next, Friday. We have x1 plus x2 and then next one, Saturday. $16. Next is x3. Ito. x3. 4, 5, 6, 7. Ayan. And then of course, may non-negativity tayo whereas your x1, x2, x3, x4, x5, x6, x7 ay greater than or equal to 0. Questions? Medyo komplikado, tama? Yes, komplikado po sa ngayon to. Pero ito po yung kalimitang application ng operations research linear programming. So, kung i-graph mo siya, ay komplikado kasi 7 decision variables. So, 7D, 7 dimension. Okay. Now, question. Questions? Mukhang wala. Walang questions? Okay. So, once again, this one is quite complicated. Pero, napauna eh. Okay. Yan. Ayan. Pero, syempre, not all the time naman ay ganun yung problema. May mga cases na non-linear programming na itatransform natin into linear kasi ang linear mas madaling gamitin. Like for example, ito yung mga non-linear equations. Yun. Sa linear, may tinatawag tayong convexity. So, kailangan daw convex. Masasabi daw natin na a certain function is convex if all x and y in a line segment of a curve joining, ganyan, function of x and the function of x to y and the function of y lies above the curve. So, tingnan natin. Ito, just to simplify things. Lies above. So, pag nag-connect ka ng dalawang points, for example, ayan, for example, magdodrawing ako ng, paano ba? Ganyan yung curve natin. Ayan. Pag humanap ako ng isang point dun, and another point dun, pag pinag-connect ko sila, yan, dyan ka na. Kailangan daw nasa above siya. And then, no intersection. Masasabi daw natin na convex yung isang function. Ang convex, ibig sabihin, pwede natin siyang magamit sa linear programming. Kasi kung hindi siya convex, hindi na linear programming yung ating gagamitin. Okay? Another example, itong bilog. Any point, ito, tsaka yung point na yun. Ayan. So, nasa loob pa rin siya, which is, masasabi natin siya i-convex pa rin. And then, we may use linear programming. I-convert nga lang with conversions. Kasi itong function na to ay naka-squared. Ayan, naka-squared siya. So, i-convert natin siya into a linear programming. Now, let's take a look on this several function. Function of x greater than is equal to x squared. Ayan, so pag naglagay ako ng isang point doon at saka isang point doon, ano mangyayari? Ito yung point niya above. So, ibig sabihin, this is a convex function. Similarly dito, pag nagganyan ako, it's also a convex function. Ayun, itong point na to, naglagay ako ng point doon, nasa ibabaw, hindi siya convex. Okay? Kasi nasa ilalim, below the function. Ito naman, saka yun halimbawa, pinagdugtong ko, may intersection, so non-convex. With, ayun o, may intersection dun. Ito kaya. Itong point na to, naglagay ako ng isang point dun, pinag-connect ko. May intersection ba? Wala. So therefore, this is a convex function. Ito. Saka yun. Pag pinag-connect ko, walang intersection. So that's a convex function. Ito. At saka yun. Pag pinag-connect ko, or kahit na anong point, walang intersection. So it's also convex. Ito guys. Halimbawa, itong point na yun at itong point na to, pag pinag-connect ko, nasa outside na siya. Or ito, at saka yung function na yun, pag pinag-connect ko, ayan, hindi lang masyadong ayos. Ito na lang. Ayan. With intersection, therefore, ito ay non-convex. Ito naman, itong point na yun, at itong point na yun, pag pinag-connect ko, once again, may intersection dun. So this is also a non-convex. Similarly dito, pag pinag-connect ko yun, at saka yun, ayan, nagkaroon ng intersection dun, non-convex. Question. Question about convexity. So to know more about that, please check yung video na to kasi mas maganda to. Ayan, or itong vlog na to. Okay? Next. So sabi daw, the max of several linear function is convex. Tingnan natin. Paano natin nasabi yun? Ayan. Let's say ito. Kung ito-drawing natin itong function na to, siguro mas madali. Gawin na lang natin sa Jamboard, sa demos. Kaso wala yung demos ko. Okay, sige, okay lang. Ayan, kunwari maayos. Function of x is equal to x over 3. If, paano natin ito ika-graph? So, if, paano to? Okay. So, para kasi siyang y is equal to x over 3, ano? Then, if x is equal to 0, anong y? Y is equal to 0. If x is equal to 1, anong y? 1/3. So, medyo alangan. Pag ganun yung ginawa natin, ano? Sige, palitan natin. If, ano ba mas madali? If x is equal to 3, y is equal to 1. Hanap pa tayo ng isang point. So, ito yung isang point. 3, 1. Okay, 1, 2, 3. Ayusin ko lang ito. Ilapat ko lang. Okay, please lumapat ka. Okay. 3 by 1. So, ito yung isang point. Ito yung isang point. Sa isang point, napan pa natin ang isa. If x is equal to 6, y is equal to 2. Tama? So, 6 siya, then 2. So, ayan, kunwari, ayan yung kanyang, ito yung function of x is equal to x over 3. Next, function of x is equal to 3. So, paano yan? Anyone? Paano natin ilagay? Parang y is equal to 3. So, asan si y? 1, 2, 3. Palitan ko lang yung kulay niya. So, ayan yung itsura ng curve niya. So, this is called the function of x is equal to 3. Sana tama yung lagay ko. Medyo mahirap talaga. Next, ito namang isa. Oops, ano nangyari? Bakit na-delete? May umibo po. Sino to? Okay, na-delete siya. Nawala yung isang function. Sige, okay lang. Okay, ito. Okay. So, ito yung isa. Function sub 3x is equal to 5 minus x over 2. Yan ang pinakasimple. 0, y is equal to 5. 0, 5. Ito siya. 1, 2, 3, 4, 5. Then x. So, y 0. If y is equal to 0, 10. Tama? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ito siya. Okay, ang galing ko. Okay, so ito yung function sub 3x is equal to 5 minus x over 2. Ngayon, anong gagawin natin? Sabi doon kasi dito, the max of several linear function is convex. So, kung ano ba yung maximum dito? Lagyan ko ng kulay. Ang maximum ng line na yun ay itong portion na to. Sorry, ang pangit. Ito. Ayan yung red na yan. Okay? Yan yung maximum nila. Ang maximum nitong point na to, dahil nga may intersection, is ayan. Then, ang maximum ng function na yun, itong point na yan. Ngayon, is it a convex? Yes. Yung red line na yan is a convex. It's a convex function. Ibig sabihin, itong statement na to is correct. The max of several linear functions ay convex. Okay, so yan yung itsura niya. Ito yung pagsasat sa kanya. Okay. Okay, sige, skip na natin to. So, another way, another approach nga to write down yung ating model. So, from this function of x, we can use just a simple maximize x z greater than x over 3, z greater than 3, z greater than 5 minus x sub 2, whereas our x is greater than or equal to 0, less than or equal to 15. Ito, bakit po less than or equal to 15? Kasi kung mapapansin nyo dito sa point na yan, yung x natin dito, 0. Yung point natin doon na consider, I think this one is hanggang 15. So, yun lang yung tiningnan nilang points. Hanggang dun. So, 15 na yun. So, x is equal to 15. Ibig sabihin, yung range ay mula 0 to 15 lang. Yun lang yung consider nila sa function. Okay? Yan. May mga constraints tayo na nakalagay sa non-linear. Pwede natin gawing linear. For example, yun sa kanina, at least 30% of the workers have Sunday day off. So, nakalagay workers off on Sunday is equal to number of, ito yung case ng postal office. Workers on Sunday divided by total workers greater than equal 0.3. At least. Ang ibig sabihin, pinakamababa ay 0.3. Ibig sabihin, pwedeng mas malaki sa 30%. Naka-ratio, di ba? So, paano natin siya gagawing linear function? Kasi ito, hindi siya linear. Simply, by cross-multiplying it like this one. So, ito, magiging siyang x sub 1 plus x sub 2 greater than equals sa 0.3 multiplied by x sub 1 plus x sub 2 plus x sub 7. And then, kung i-transpose na lang siya, we have 0.7 x sub 1 plus 0.7 x sub 2, transpose natin, minus, 0.3 x sub 3 minus 0.3 x sub 4 plus 0.3 x sub 5 plus 0. Hindi kasya. Ulitin ko lang. Hindi kasya eh. Okay, isa pa. We have 0.7 x sub 1 plus 0.7 x sub 2, 0.1 minus 0.3 x sub 3 minus 0.3 x sub 4 minus 0.3 x sub 5 minus 0.3. Sana nagigets mo kung bakit ganyan. Minus 0.3 x sub 7. Then, i-retain lang natin greater than or equal sa 0. Kumbaga, transpose lang natin doon lahat. Okay? So, yan. Linear na siya. From non-linear, na-transpose natin siya into a linear constraint. Then, solvable na yung equation natin. Solvable na siya. Questions? Wala naman po. Okay, and then yun, napakarami. Kung gusto mong dalhin siya into reality, napakarami mong considerations. Pero as much as possible daw, huwag talagang gagayanin yung reality. Okay, kasi napakadami niyang constraint na halos magiging imposible na i-solve yung problema. So, ayan. So, in modeling, one needs to capture a lot of reality but not too much, which is true. No. Let's try to solve some problems. So, ito yung example ng paggamit or application ng linear programming sa NBC or National Broadcasting Company. So, yan. Again, very helpful. No, let's try again. This one. Habang may oras pa tayo, 3 minutes. Siguro kaya nyo na to. But then again, tingnan natin. We have article C, B, and C. Weight volume given below. Total weight cannot exceed 2,000. So, ilagay natin, cannot exceed. Ibig sabihin, ito yung 2,000 cannot exceed. Dapat mas mababa daw sa 2,000. So, less than equal. Total volume cannot exceed ulit. So, cannot exceed 2,500. Maximum. So, so, total, the cost is maximum. So, di ba, uncharacteristic yan. So, pero ilagay na rin natin. So, ang objective function, max cost is equal to 5A. Pababa tayo. Kasi ito yung ating mga decision variables. 5A plus 6B plus 3C. Then, constraint natin, subject to, pababa ulit tayo, then pababa ulit hanggang sa magamit natin lahat. We have 4A plus 8B plus 2C. Then, ayun, less than or equal sa 2,000. Next, 9A plus 7B plus 4C less than or equals to 2,500. So, nagamit natin lahat ng ano dito, next statement. And of course, non-negativity constraint na A, your B, and your C must be greater than or equal to 0. So, ang tawag nga po dito ulit, non-negativity constraints. So, ayan. And then, madali na to. I-solve. Questions? Questions? So, ituloy natin to next session. Yan. And then, pwede nyo na ma-explore itong Jamboard natin. Pero please, wag nyo pong i-delete ha. Please, wag i-delete. So, ayan. Marami pa dapat tayong problema dito. Isa-solve. Nevertheless, ano yung gagawin natin next? So, next meeting will be doing in a recitation. Next call. Yep, next meeting. So, ito po. Pa-access naman po nitong recitation 1 natin. Ibibigay ko na po sa inyo. June. Okay, so ito po, recitation, ibig sabihin kayo po yung magpe-present nito. So what you have to do is go dito sa 8-1, 8.8331, page 331. And try po based on your analysis. Wala namang mali pa dito. Ano? Okay, try to formulate the linear programming problem and do not solve it. Okay, so ito po, i-search na lang yung page 331 kasi 330 na. Okay, so done. Ayan, so punta lang po kayo dito sa page 331. Ayan, nasa pakalayo ko na. Ayan, so 331. Ito po, mula 331, ito po yung mga application na. Tunay na application ng linear programming. So you just need to model it. Okay? Imo-model na lang po to, kagaya ng ginagawa natin ngayon. But, ayun, may discussion muna tayo before yung recitation. So you have to present it either sa Jamboard or sa any way. Kayo po yung mag-share nun. Okay? With regards sa groupings, paano po yung groupings? Ako na bahala? Or kayo? Groupings, guys? Paano yung groupings? Okay, meron na kayong groupings. So, yan. I trust your groupings. Okay, and then kayo po yung magpe-present sa next call natin. Okay, that's good for 1.5 hours. Then ako dito sa 1.5. Okay? Questions? Tuloy natin the next meeting. Questions? Questions? Yep. Glenn, yes. Okay. 0.7. Sana tama yung pag-solve ko. Ano? Masyado yatang mabilis. Ito po. Kung mapapansin nyo to, 1. 1, then 3 transpose. Para kasing ganito yan. Okay, hold on. Ito kasi x1, then 3 transpose mo dun, minus 0.3 x1. Plus x2, 3 transpose mo dun, minus 0.3 x sub 2. Then the rest, ganun na. Ito, cross multiply lang. Okay? Tapos ito yung 0.7. Questions? Sorry guys, ang hirap. Ang pangit pa ng sulat ko, pero sadyang ganyan eh. Questions pa po? Okay, so, ano? Yes, Nika? Yes, ba? Yes po. by group. So, isang representative, isa na yun na lang yung mag-share siguro. But everyone can speak, of course. Okay, any more questions before we end today's call? 3 hours. Okay, questions. Wala na. Okay, so salamat guys. And pahinga na kayo. Bye po. Recordings. Yeah. Pa. Okay po, ang bahala. Ano ba nakalagay dito? Yung kagaya nung, I think, maximum of 6 yata yun. Yung nakalagay dito eh. Yep, maximum of 6. And yeah, 4 to 6. 5 to 7, sorry, 5 to 7 members per team. Yun pa rin yung gagamitin natin. Okay, so salamat guys. Recordings will be shared later. Paalam po. Thank you.